Thanks so much for being here today. I'm Greg McGuire, Henry's Managing Director. This panel is going to continue our discussion on generative AI and its applications in transportation. Our moderator today is going to be Dr. Taylor Lochrane, Deputy Director for Science and Technology and Chief Scientist at the Highly Automated System Safety Center of Excellence for US DOT. I don't know why I always think of avocados when, but anyway, Haas, okay. I do want to warn everyone that, if you don't come up with questions on your own, we're going to start asking ChatGPT to make up questions. So you got to start thinking of some now. Our panelists today, Milena Boychev, Global Head of Autonomous Driving Technology for Amazon Web Services. Welcome. Dr. Karthik Duraisamy, Ph.D. Professor, Aerospace Engineering here at U of M. Dr. Devesh Upadhyay, Technical Director of AI, Machine Learning, and Autonomy at Saab. And Dr. Ziran Wang, Assistant Professor, Civil Engineering at Purdue. Please have a seat and take it away. Thank you.
Good morning. First off, thanks to Henry and Victoria and Greg and those of you that coordinate this event. I think these events are so important for us to finally get in person and talk about them. So in the art of collaboration from our government leaders here in the state of Michigan, let's take 2 minutes. I would like everybody to look at the person to your right and left, and you're going to say your name, say hello to one another, because we're here to collaborate, and you're going to ask them this question. Do you think transportation sector will adopt AI solutions in the next decade that become the new norm, or is it just hype? So we're going to ask that. We're going to pull that answer in a few minutes. So take 2 minutes, introduce yourself to your table, and we're going to get started here. All righty, we're going to regroup now. I hope you guys got to meet a partner, a friend, a new colleague. So we're going to start to do some collaborative thinking, collaborative discussions today. So with a poll of hands, how many of y'all think it's real? This is going to be the new norm in the next decade. All right. Now the other group, how many of y'all think it's hype? Okay, great. No one thinks it's hype, so we're going to have a great conversation today. All right, so we're going to start off with our panel with the first question. And how do you see generative AI in transportation, the industry over the next decade? What's your vision? What do you think the future is going to look like? Devesh?
Yeah, that's a good question. So when I think generative, the first thing I want to do is figure out what we mean by generative, right? So I think get that definition out of the way. So looking at generative, and we have been doing generative in some sense. Some people may call it extrapolation, some people may call it generalization, but there is this inherent idea that neural nets or machine learning or deep models, under scaling laws and compute capabilities, are able to learn inherently the structure and data. And through that, you're no longer just extrapolating under a fixed understanding of structure, but you're creating novelty. Now the challenge is, how feasible is the novelty? Are you creating nonsense chemistry, or are you creating chemistry that's real? Similarly, in the traffic space, in the transportation space, I think some of the presentations already happened. We talked about traffic scenarios, incidents, simulation, possibilities of how do you expand or modify transportation in general. So I think those are the kinds of areas where the dimensions are very large, where generative methods will give us a broader perspective on how to plan, do decision making, do prediction, and do perception in general of where we are headed and how do you want to plan transportation. So that's how I think where generative AI is going to play.
Karthik, what about you?
Yeah, I think I agree with, and I also quite enjoyed the previous presentation. So one thing I want to bring up is, maybe two things. So the first thing is, we've been using data and AI, whether we acknowledge it as AI or not, for a very long time. But what is different is earlier we used to take labeled or unlabeled data, more or less structured, maybe a little bit unstructured. And we were able to use that maybe to make predictions, etc. Right? But now, I think Devesh was also alluding to it. Now we can use metadata, right? Everything in a sense is data. It doesn't have to be organized. The ability to process very, very different types of data, which we may not even have thought of as data before. right? To take that and not just make predictions, but also derive insights, generate ideas, hypotheses. So that's one thing I want to bring up. The second thing I want to talk about here is unprecedented collaboration, right? The opportunity for that. So I don't work as much in transportation. I have a little bit of it, but I work more on the scientific side of things. And we are looking at scientific foundation models or foundation models for science as something that for the first time in the history of science, we have a platform where literally tens of thousands of scientists can contribute various things on the same platform, right? So what does that imply for transportation? We used to think, people who do vehicle design were doing vehicle design, and then there are the traffic controllers, then there are the urban planners, and then there are so many people down the chain, and all of these tasks were unique and distinct. But now there is an opportunity for all of this to come together digitally under the same platform. To me, that is, I think it can be incredible, what we'll see. So even if many of the tools that exist, even if language models don't get much better, even if the multimodality doesn't pay off as much as we think it will, the ability to connect all of these different kinds of people that we've not connected before, I think is going to be revolutionary.
Yeah, that's an excellent response. Melina, what's your idea of the future?
I work in a niche. If you look at the transportation field, is as Justine mentioned, is marine and aero and on road, off road, etc. I work in a very niche domain there, the autonomous vehicles, and ML and AI have been essential to the development of autonomous vehicles so far. So it is. And autonomous vehicles are safety critical systems, right? So we have been using ML in a safety critical systems in a different ways for autonomous, but also for ADAS systems in passenger vehicles. They have been there with some risk mitigation as human in the loop, people observing and being liable for what's happening still on the road. In autonomous vehicles, we have them with different mitigation systems in place. And the problem in both domains have been, how do we scale? How do we move from one city to the next one? How do we move from one weather condition to the next one? This is what we call operational design domain. How do we expand the operational design domain? With the current robotic methods and AI ML that we have, this has been a challenge. And somebody mentioned here, I think one of my colleagues talked about distribution shift, etc. When you move between different parts of the design domain. Now, I do believe a bigger models, just by the sheer fact of the scale and the data you can train, and because it is unlabeled data, you can feed in more data. This operational design domain can be expanded in a much quicker way, so you can generalize better. Now, there are different problems, and we will talk on the panel about them, I hope, about them, but I do believe that the Gen AI, the LLMs that we see will progress us towards better scaling, easier scaling of ADAS and AV systems.
Ziran, what about you? What's your future?
Yeah, I think a lot of points are well said by my colleagues and also by Dr. Ye by his presentation very nicely. Going back to the point that Henry made at the opening remark, the curse of rarity, right? All those corner cases that we have in transportation, like the Duraisamy cases mentioned by Dr. Ye, or a lot of autonomous driving cases, we can use generative AI or large language models in specific to understand all those things, to detect anomaly, and then to make predictions and decisions more safely or in a more robust manner, and to address all those corner cases that are not included in the training data of those machine learning models. I think generative AI have that power to address that, and will be very hopefully that will be something that we'll see in the future.
Yeah, at the Department of Transportation, our top priority is safety. So when I think of safety, when I look at AI, the question I have for you, Melina, is what kind of strategies can we take when we think about how we can apply safety into these systems as they become developed and injected into our transportation system? Melina.
Yeah, I can talk about this. So again, I don't want to talk only about my niche scope. Is one of the most interesting when it comes to safety. But first of all, I think when we talk about safety, it really depends on the risk level that the system poses. Yeah. When we have for example, travel optimization agents, as the beautiful presentation also mentioned, the safety means something different than when we have autonomous system on the road. Yeah. It is important to be cognizant about the harms and risks a system poses, and this is the starting point of everything. I would like to talk, when I talk about safety, I would like to talk about low and medium risk in terms of harm to people's life, property, etc., and then about high risk, and then about something that, in my opinion, still doesn't exist, about this general threat of AI over humanity that has been so populistically talked about in the press. So when we talk about low and medium, what I mean is, again, optimization of travel plans. This is, for example, helping maintenance, repair, and overhaul technicians to pull information from different sources and to have a better plan how to manage airplane or a vehicle, predictive maintenance, chatbots helping you book your travel, etc. This is safety means something different. Safety means is my information that I'm pulling accurate, right? Is there offensive language? Is there bias in my data? Do I infringe IP? Do I infringe privacy of people? The privacy of people. So this is one corner of safety of Gen AI systems, and I think what companies have to do is, and it starts with the data, and I cannot just emphasize more on this one. Where does your data come from? Be very intentional where the data comes from. Be intentional about the freshness of your data. Have a person in the loop checking the answers. Have automation and KPIs about bias, accuracy, freshness of the data. Have values around what you want to do with Gen AI in your business. So then I want to move to high risk systems as autonomous vehicles. We have, and there are a couple of things people have been doing. So we have on the one side, we have frameworks and regulations and guidances provided by different government bodies, agencies, etc. We all know at the moment that there is some these systems cover the development of high-risk systems, but they don't address how do we ensure the safety of ML and Gen AI models. Now, AI and Gen AI in particular models, they are to a certain extent covered by the existing frameworks and standards, but not entirely. So we have, for example, in aerospace, you want to know any risk and any harm, and you want to absolutely be able to mitigate it from your system or to recognize it at first place. In autonomous driving, the bar is a bit lower because the harm is less, but you still have a very high bar of detecting weakness and failures in your system. And then there are different. I want to mention a couple of techniques that we use. You have the frameworks that give you a very good top-down orientation where I'm in the risk. We have ISO in automotive. There are different categories in aviation, etc. So they give you they give you a guidance where you are in the risk level. They give you a guidance how you can standardize. There is a gap, the AI ML. What we can do is, and I will talk about a couple of strategies just to get a little bit more concrete here to give you a sense, because autonomous vehicles has been dealing with this problem for a decade now, and there is some experience. And on a high level, I want to share it with you. First of all, you can build deterministic system. Yeah, you can remove your stochastic gradient as a way to pull data. And every time with the data you have, train the model and this model to give you the same result when you with the same input. So you can build deterministic systems. You can decompose. I mean, this is something we all do. We decompose the system in different modules, and then we look at different modules and then find the weaknesses in this module. Yeah, it's easier to evaluate first the different parts and then how they play together. So decomposing is one strategy. Determinism is another strategy. Adversarial robustness. So try to really test, put the modules under stress test and try to find all the weaknesses it has. Testing different domains, operational design domains. Have a mitigation strategy. Have a mitigation strategy, what we call redundancy in the system. For example, you have a camera, put another sensors, LiDAR, radar, use help like HD maps to give you some a priori knowledge about your environment. Test, try to, and sometimes, the problem, the AI, ML, and the Gen AI systems also give you an answer. So as EA mentioned previously, you can Gen AI because the essence of it is a distribution of a data, can give you also rare cases. This is how we have been using it in autonomous vehicle, detecting edge cases and rare cases, what we call the long-tail distribution. So these are different strategies that you can do that we have learned over the time in autonomous vehicles and ADAS systems. And then I want to talk about the last one, and this is the general threat to humanity. This is, we don't have intelligent system, a general artificial intelligence as of today. And as intelligent ChatGPT appears, it's an autoregressive model that generates one token at a time, and the next one is picked not by some intelligent function, but the best distribution for the next token. So there is no general artificial intelligence, and I think talking about something that doesn't exist today, solving problems that are not there at the moment. There was one very interesting slide. I don't know if you pick it in the ES presentation. I loved it about the agent. This was the most interesting slide from my point of view because it somehow captured the essence of this, an agent that can move between different domains. So I can take, for example, the model of my autonomous vehicle and put it on a robot and it will wash my dishes tomorrow. So this is the idea of general. And this was a bit on a very abstract level captured on this slide, where you have a self-critics, you have some very sophisticated innate cost function and motivations, etc. But this is not the reality today. So my general advice here is let's try to solve this problem when we come anywhere close to having such a technology, and at the moment we are not there. And one last thought. So I'm sitting here, and it's important. I'm over speaking, but I understand this. When it comes to safety, it is so important to have diverse perspectives. Just build a team that works on safety, that has diverse perspectives, comes from different industries, different backgrounds, different gender, ethnical background, etc. This is something that we all can do and contributes immensely to look from different perspectives and make a system more robust.
That's excellent. And that's an area that we're kind of focusing on, the federal government, is AI assurance. How do we assure that these systems from the life cycle of beginning to implementation are developed properly, and how can we really trust the output? So we really have to be diligent on the entire life cycle. So Devesh, when you work closely, from industry on the civilian side and now working across the Department of Defense, I mean, how does safety, what does safety mean to you when you start to look at these different industries and sectors in a multimodal environment?
Yeah, it's a very, very interesting question. And my transition from the automotive to defense area has also been very interesting. So when I was in the automotive space back at Ford, I attended one of the initial workshops put together by NIST, when they were still struggling to get definitions on what is safe, what is reliable, what is robust, what's explainable. And we had people from Microsoft, IBM. The panel was pretty rich. We were still hammering out the terms and terminologies, right? And then I got involved with ISO and their new regulations called PAS 8800. It has been 3 years we've been working on it, or 4 years now. ChatGPT wasn't on the horizon then. We were still struggling with pure and simple perception systems and decision making in the autonomous space. And again, terms, terminologies, regulations across countries, borders, domains, everything was so confusing. And we just kept adding chapters and chapters because we said, well, someone said, well, we need to have a verification validation as a separate chapter. Then we said, well, architecture has to be separate from hardware. And then how do you account for the ASIL? Does ASIL transfer from standard automotive to AI-enabled systems? What is an AI-enabled system? Because you would have traditional, components with classical solutions on it, and then some parts would be interfacing with an AI system. So what does that interface look like? So all of these questions, so now we have 15 chapters, I guess. We're meeting, one of the last meetings in France, and we've already planned a second session because now generative AI came in. We had no chapters for that, right? I mean, we had generative AI at a much lower scale. Now this it's on steroids. And so now we want to say, well, how does that affect it? So that's going to be the next phase, I guess, 3 more years. Transitioning to defense, now that's a very fascinating area. I did not have that exposure before. The domains are very different. Like Lena talked about operational design domain. So the ODD changes rapidly. So you have peace zones where there is peace and harmony, and then there is conflict regions, and there are regions that are going to become conflicted, right? Indo-PACOM, for example. So the question becomes, how do you transfer, and to her point, how do you transfer technology you've developed in one domain to an evolving domain for which you had no idea was going to happen? Now, you cannot generate your way out of scenarios that are influenced by socio-economic, political, and all these other influences because we haven't really, these are human generated, which is kind of difficult to forecast and predict. Some we can, some we can't. So there is this impetus now through DARPA and through Office of Naval Research and the Army DEFCOM and DIU, the Defense Intelligence Unit, that wants to do very rapid transition from sim to real. So you simulate, transition to real with minimal gaps in performance. So models that what is called models failing silently under distribution shift and domain shift, you don't want that in fields where the trade-off between false positive and false negatives is actually very critical, right? If you have a false positive, you have catastrophe in a war field. If you have false negative, your warfighter is at risk. So there are all these complexities that are now becoming part of how do we introduce machine learning and generative AI and data. Data is critical because ultimately we are now no longer relying on the support of physics, but we're relying on extracting that same information from data. So the richness of the data, not necessarily amount of data, the richness of the data and the coverage of the data is actually very critical. So there you then talk about synthetic versus real, how good is the synthetic data? So those kinds of questions are all bubbling up and it's just going to be lots of work looking forward.
Yeah, so Karthik, how do we balance this relationship between innovating and responsibility and governance when we think of these systems, and so we can keep moving forward?
Well, I think you kind of answered the question in the sense of balance, right? And I think it was already like mentioned by Mileno, to bring very, very diverse people and diverse stakeholders, right, from different parts of the spectrum. So I think that's one thing. And then standards have to be local, regional, and global, right? And these 3 things will have separate requirements, but being able to coordinate and work on all of these, I think, simultaneously is something. But end of the day, it's just going to come down to getting many diverse perspectives from different stakeholders, right? Because as I mentioned just a few minutes ago, this is a platform that many different people can collaborate on, right? So to bring all of those perspectives in and then balancing risks and opportunities, I mean, there is no easy answer. So I'm going to flake out and give you that high-level answer. But it's a long process. It has to be done judiciously and bring different people at the table.
And it's interesting, when we look across the world, the global community, how lots of countries are approaching the regulatory framework very differently.
Right.
So that's kind of good and bad. It's bad because we all, not adopting something similar, we're not doing things together, but it's good because we're maybe seeing if there's a better way by learning with each other, with our global community partners. And so I think that's where collaboration, international collaboration is going to be very important as we start to look at, these issues. So, when it comes to what are the needs, where's the research? What research do we really need to do? So Ziran, what do you see as the future of the research and investments that need to be made both at the federal and the state and local level?
Well, it's a good question. So probably I cannot speak too much on the federal level because you are from federal government, but from the institutional level as well as from the industry level, because I worked for Toyota for 4 years, and actually right now we're also working with Toyota on some of our projects on using large language models for autonomous driving. So we think there's definitely a trending need from the industry, especially from Silicon Valley, to incorporate generative models like large language models to their vehicles to help their existing AV stack, perception, planning, control, to solve some rare issues. Actually, two of my students they got invited to do internship, one at Toyota, one at Cruise, because there is really this huge need of incorporating all those new technology into our transportation domain and help all those products, existing products, to better solve all those issues. And that's from the industry side, from what I know. Institutional side or university side, as Taylor just mentioned, there are a lot of work overseas as well. Dr. Ye just mentioned work from Alibaba. There are fantastic work from Shanghai AI Lab, another research institution in China. But here in the United States, universities like all those top engineering universities, Stanford, and Berkeley, MIT, and including us, Purdue, we have done a lot of work in, and also University of Michigan, putting the edge of, this domain of research, trying to see what are the possibilities, right? We're not looking at specific products, but we're looking at all those new possibilities that we can empower our existing transportation systems and our research by using generative AI and specific large language models. So yeah, it's a new trending research, and everyone is pretty excited about it. Yeah.
So I'm going to ask the panel, what is your favorite application of generative AI that maybe you're working on back at your home base, or it's something that you follow and you're very interested to see how someone else is really applying these tools to a specific utility?
Yeah, so I'll just piggyback a little bit on what was just said about research. And the reason is because I do get invited to universities to talk about one topic and it's not generative, it's AI in general. Departments that are not computer science are struggling with enrollment. And the question I'm asked or to discuss is how do we manage that? Why are students not wanting to study chemical engineering or civil engineering or mechanical engineering? And having built a group inside of Ford, and Jim is here, Jim Piskowski is here, he was the the mentor and supporter for that actually looked beyond AVs and said, how can we apply machine learning, data science into science, engineering, and manufacturing? And so when I talk to universities, I tell them it is the responsibility to a large extent of the professors, the teachers, the university itself, to find ways to integrate machine learning. Like Karthik said, we've been doing this forever. It's not like mechanical engineers and chemical engineers know about gradient descent. They've known it forever. It's not anything new. We've dealt with data forever. Now, metadata, perception data is new sensors, but we know how to deal with these things. So just to keep it short, I think there is research that also involves how do you build a curriculum to integrate machine learning into every discipline in a university setting. Now, one of my favorite things in generative AI, again, going back to when I was at Ford, we had started work in material discovery. So if you know about material science, finding a novel material takes 10 to 20 years. So at that time, we were studying, the thought process was, given the ability of compute and machine learning and data, and the experience of subject matter experts as historians of information, that's what's used in RAG these days, or human feedback RL, can we start using the power of these tools to quickly mine the large space of materials, to create functional materials in an inverse sense? So you tell me what you want, and I'll find you the material. So that was a project we kicked off. We put a lab together. We had 3 or 4 people that we brought in, and these were people that had engineering background, but were also very good at machine learning techniques. And one of the first things we did was we found a material in 6 months that was graphene, was a polymer actually, which was able to do a better NVH mitigation. So the next step was to, well, can we now find biodegradable materials or materials with more cellulose so that its carbon footprint is reduced, get plastic out of the way. And then going further beyond that, we said, well, let's take this and see, can I now design my vehicles to not only look really cool, because generative has the power of, again, giving you these novel ideas or novel outputs that you wouldn't have dreamt of. So what the team did at Ford was we looked at all the really cool looking car shapes, and actually Toyota TRI put it in production, but we patented it also before that actually happened. You look at all the cool car shapes, the geometries, and from there you generate something that is not out there. So you create this really cool looking geometry. So maybe you want to make your edge look like a Mustang, I don't know. You can do that. But once you do that, though, you do not know if it's aerodynamically feasible. Is the drag good? Is the fuel economy going to suffer? How is its road performance? What's its dynamic behavior? So now, to Karthik's point, you put the science on it, right? You take the shape and you do your aero studies or you do your CFD. And you're combining all of that, you now have this tool that really is very rapid and very rich and starts iterating on designs that are feasible. And so those are the things that I thought were really practical and very useful. And we extended, one last point, we extended the materials work. We were just before I left Ford, we were extending that to battery chemistries. Now, if you know the electrification, we've talked about electrification, it doesn't happen without batteries. And batteries rely on materials, and that's a very, very resource intensive and distributed globally problem. We don't have all the materials. So how do you find these chemistry combinations that allow you to not only manage your supply chain for battery materials, but also have enough to be able to support the demand for EVs. So these were some of the things that we experimented with, and I thought they were really practical applications of generative AI.
Thank you.
Good. Yeah. So maybe I'll give you 3 for the price of 1, but I'll get through them quickly, right? So the first thing, I think personally, I've been, over the past year or so, I've been looking at many different disciplines and trying to identify problems that were successfully solved by AI and actually brought value, right? And I was looking at characteristics of those problems. And I think one thing that I want to bring up is AlphaFold. So this completely revolutionized protein structure, right? Just from literally letters, sequences of amino acids, you get the entire 3D protein structure. And examples like this are very few, okay? So it's very easy to go to any field and then do some low-hanging fruit and say, hey, look, AI did this, right? But there are a few problems where it has really revolutionize. So that's, I think, the first part of the answer to your question. The second, some of these things we're also working on right now. So all of the buzz, much of the buzz around generative AI has been coming from these very large monolithic models like GPT-4 and other large language models. But what is happening now is, and these are all general models, right? What is happening now is how can we personalize them? How can we customize them to very specific scenarios? And how can we do these using lighter weight models? Well, you don't have to believe Apple when they say you can train and you can fine-tune an LLM on the next iPad. But I also want to say that it's not that far in the future where pretty much all of us will have the ability on our personal devices. Maybe it's a phone, maybe it's not 2 years, maybe it's 5 years, where we can have lighter weight models and intensely customize and personalize them. Of course, there are concerns about privacy and risks. I'm ignoring that just for the moment. But for these agents to completely understand our context, work on our specific scenarios and our specific contexts, and being able to give ideas and hypotheses and plans, I think that is, it's coming. It's already happening. But I truly believe, just like, 3 years ago, people didn't think that, 1 billion people will be using a GPT-4 or something, right? And the same thing, I think, in a few years, 1 billion people, and it's not 10 years, may be customizing these powerful models for their own. So I think that's something I want to bring up. And the last thing is there is also some work. So none of these models are grounded by reality. They are kind of open loop trained. But there are quite a few researchers working on bringing reasoning capabilities by construction, right? In some senses, it could be like pinning it down to the physics, if you know that. In some cases, it could be basic mathematical rules that will never be violated. So those kind of additional grounding. So these are some of the things that are pretty exciting for me.
Thank you. Melina, what's your favorite application of AI? Melina.
I also, while listening to my colleagues, couldn't decide between two. I want to talk quickly about both of them. I'll start with a more realistic one. We saw the Zora video on screen in the previous presentation. For me, coming from autonomous vehicles where the real world is so essential, understanding what's happening in the real world and being able to predict the next couple of, the next 15 seconds in it is essential for safety too and efficiency. For me, one of the most exciting fields at the moment where I do know big tech companies are working on is being able to tokenize the physical world. Yeah, tokenize and encode the physical world. We have done this with language, and we have done it beautifully. It works. You go use ChatGPT, and it captures the nuances of your language. It knows what is essential in this context, etc. Now, how do we do this with the real world outside, with the physical world? And you watch Zora, we are not there, You go on Zora, Gemini, whatever it's pronounced, and there is a big disclaimer, this is not physically accurate, and it works for the next 15 seconds or a minute. But we do need for some safety critical systems, we need 3D awareness, we need temporal, geometrical accuracy, etc. Yeah. We are not there. I'm super excited to see what's happening in the next couple of years. I hope in the next 2 years we see some big progress there. And he talked about material science and protein crunching, and this is all part of the same world. It's part of the same physical world and classical physics described by the classical physics, right? Now, this is also one of the interesting parts, the abstraction level you assume to solve your problem. Would there be one encoding of the physical world? Most probably not. Most probably we will have one model that encodes whatever is the relevant size of objects on the street for autonomous driving. And this will be the one, perceived the physical world, and there will be another physical world for material science and molecule. I call it protein crunching for as a lion trying to describe chemical reactions. So this is one. Then the second one is, again, I'm going back to this slide for a general artificial intelligence. Let's not call it general, but a little bit more generalized. Yeah, there is a lot of research put in there in building hierarchical systems, building short, long-term memory. These are different components of an agent that can assist you in different situations. Yeah, autonomous vehicle has a hard-coded objective: take me from A to B in an efficient and safe way, safe and efficient way. Yeah. This is a hard-coded objective. Now, when you can change and move between objectives, wash my dishes, go and book my travel, and please go and wash my car physically. These are different objectives, and then you can move to more and more and more. You can expand the space of objectives. So this architecture that was presented is I see it over and over by different scientists. Just keep working on it. Keep working. One of the main points is the cost function, the objective. How do you modulate the objective? When I give you a small example, when you tell go and wash my car, if the robot cannot move because in between is the child, you have to make sure that the robot doesn't just push the child to a side and harms it, right? These are the implications and this is where people start getting a bit nervous. How to modulate this? How to put ethics and moral in this more general artificial intelligence? Very philosophical questions. I will not solve them today. But to start thinking about it, to start thinking about the architecture, technical architecture, and then the moral and philosophical implications is a super interesting topic, and I'm looking forward to see what's happening there.
I'll probably quickly summarize the things on our radar in our research of autonomous driving. Probably also two of the applications. One is scene understanding. I just mentioned all those corner cases. Think about, probably you have seen that on, social media. A truck is carrying a signal head, traffic signal head, but that traffic signal head is not on the ground, but it's on the truck, right? But the Tesla, I think it was a Tesla, detecting that as a functioning signal and keep, getting, commands to the vehicle to either doing some, speed change or stop like that. That's scenario one. And scenario 2 and 3 is, there is a stop sign on the billboard, right? Or there is a truck or some vehicle on the billboard, some advertisement on those commercials. And then the perception module of the vehicle detect those as, the way that you have to stop at the stop sign or you have to yield to those oncoming traffic. All those cases can fool your existing perception models, RNN, CNN, transformers. But having Gen AI, specifically large language models, to do the scene understanding, to know, okay, hey, that's not the things that you should pay attention to. Those are not on the ground. Those are on the billboard, on some other vehicles, and that will help a lot to solve all those corner cases. So we think that will be probably the things that many researchers are looking into right now, a top priority for LLMs for autonomous driving. The second thing is the things that we focus on is called personalization, as Karthik just mentioned. But we focus on from the human autonomy teaming perspective. When we talk about autonomous vehicles, we talk about vehicles that are driven by themselves, level 4, level 5 in the future. So drivers are not in the loop anymore, but passengers still are, right? So passengers, they have their own preferences of how the vehicle should drive, should hit the curves, should overtake any other vehicles and things like that. So we leverage the power of LLMs to facilitate the human autonomy teaming process, meaning the vehicles will be able to understand all those implicit needs from the passengers. The passenger will say, hey, I'm going to pick up my kid from the daycare, or I'm late for my meetings, or I'm late for a seminar like this. And then LLMs will be able to understand the context, do the reasoning, and then make decisions accordingly to the vehicle to either change the speed to a faster speed, to choose a route that is more convenient to pick up your kid or things like that. And we think that will not be possible without LMs. Based on our current NLP models, you have to give very explicit commands. But LMs, they're really good at understanding all those implicit commands and make the connection between your preference to the vehicle decisions. So that's our priority right now for personalization.
I want to pull that thread a little bit. I don't know if you guys saw, there's a video that was just recently posted online of one of the self-driving car companies driving behind a vehicle that was pulling a trailer that had a tree. And so, and you can just look at it. I don't have any input or data, so this is just my perception, I guess, a human perception of watching it. And it looked like it was seeing an obstacle in front of it that it wasn't recognizing as a tree, and it should get out of the way. Then it realized that it was leaving the lane lines. It realized that it could see a vehicle and trailer, and then it would go back. But it kept oscillating. And I don't know why it kept oscillating, but that's like what's kind of needed in these models is to kind of keep training them over time. So my question really comes down to, because I see a lot of our state DOT folks here and city officials, public perception. So if we have these amazing tools, how do we tell the public and how do we help build confidence with the public when we want to deploy these tools onto public roads where we see the value, we see the opportunity, the utility, but how do we assure the public that these tools are safe? And I'll open the floor to any of the panelists on this question.
Probably I'll take the first step very quickly. To build a trust for the public, you have to explain all this technology. Probably not everyone can explain as good as Dr. Ye just did, but explaining all those details, especially the limitation of those new models, right? And we will know when will those models will be functioning. Probably some cases they will not, and then know the boundary of such technology is always helpful to allow the general public to have a better trust on technology like this.
Yeah, I just do a better job than we did managing COVID. I mean, it's a snarky comment, but I think there is a bit of truth to it, and also picking up from what he was saying. We need to be explicit about the limits of the technology, but also, I think, educate the public on, the current state of, what exists right now without the technology, right? So it's not 100%, right? I mean, it's a sliding scale, and people need to understand the risks of using this technology and the risks that already exist. And I feel we don't quite, it's either this narratives are focused on this or narratives are focused on that, right? And the other thing, I think, broad education about uncertainties and the inherent stochasticity. I think you mentioned you can do it deterministic, but there is uncertainty that we can never get rid of.
Oh yeah, the model is deterministic, but still the environment is so uncertain.
Correct, and being transparent about these things in a palatable way, I think, would go a long way.
Yeah, it is a tough question. That's why I asked it. Because it makes us all as a community start to think about this. Because I think when we're talking about the safety of these systems, we have to think about that from the beginning and not just wait till the end. Because that really could hurt innovation, especially in our country and our global community, where we take safety as a #1 priority in every jurisdiction, at least in the United States and across the world. But education, I think, is prime. So since we are here at the University of Michigan, what are ways in which we can improve our workforce and we can build upon the education? I know you dabbled on a little bit on some of the other disciplines, maybe having lower enrollment. Will these tools kind of enhance the workforce and enable newer types of jobs and newer types of workforce for the future? So what's your outlook on the education that may need to be required to help support this technology moving forward?
Maybe we should start with the professors.
All right, I think I'm a little bit maybe going against the stream here, but I believe a solid foundation in classical, what we viewed as classically important, I don't think we should give that up. In fact, I think we need more of that. And I think if we have, and there is a huge risk now, especially, in many fields where, including deeply scientific fields, where there is this wave of excitement about AI, which is good, but at the same time, you're losing some of the very core skills, right? So for most of us who've been brought up traditionally, I think making that jump is easy because we know more than what the AI does. So not giving up that foundational layer that helps us understand and manage these systems better, having that knowledge when it is wrong, when it is possibly wrong, knowing at a deep level when it's supposed to work, when it's not supposed to work, risks, uncertainties, thinking stochastically. So all of these things are about AI, but this understanding comes from the more classic education. And I think that's it's a big risk. I mean, you hear this debate in California to give up algebra for data science or data science for algebra. I mean, that completely blows my mind. So I think not forgetting the fundamentals as something that helps us navigate these technologies and not just become users of tools that we don't understand.
Yeah, I mean, I totally agree with Karthik. I think that building upon the classical, so one of the things, there's this whole area called physics-informed neural networks. And this is even before that became the thing, and we were in my team already thinking, well, if I have to relearn the physics from data, am I not just putting additional burden on a network? Why can't I just use my physics? And every model is uncertain or has gaps, build that with data. So that was the birth of a hybrid approach, and Karthik's been working on that, and then PINS came around, and we did some work with Karthik as well. But to Karthik's point, I think way back when, I will not take names, but one of the earlier courses mentioned that you don't really need to know math or algebra to do machine learning. That same group is now teaching a new course called the Mathematics for Machine Learning. So these are kind of things that you can say it's evolution and you learn about things, but I totally agree. I think classical, and we talk about, right, when you say, well, your data is bad, go to the subject matter expert. What is the subject matter expert? If you don't have classical, you don't have subject matter experts anymore. So then you're totally relying on data, and that's like flying blind, right? You cannot learn your way out of these problems just by throwing data at it. If you look at the scaling problem for large language models, look up scaling laws for machine learning. They talk about compute, data, and the number of parameters, right? The number of parameters always wins out. I mean, there was a slide shown here that above, after a certain level of parameters or flops, your capability went up. The question to ask is it overfitting? Are you overfitting, or are you really generalizing? And those are the questions you have to ask. And certain problems that are safety critical, that are mission critical, for where things are more important than just an app that helps you shop. It's a critical question. I think there, grounding was brought up. All of these things are going to be very important, and the whole integration, the classical and the novel, has to go together.
I want to chime in here. It's a super interesting discussion. While they were talking, I had the different thoughts through my head. The first one is, but these models know only what we know, right? They are trained on our knowledge of classical physics, chemistry, the basics, mathematics. Then I had a second thought, maybe they are trained also on data where we didn't find any generalization rules for them, and these systems can find them. And then at the end, I arrived in this couple of minutes at a point that maybe we don't need to teach maths and anything else if we have one system with endless number of neurons that can perceive all the data around us. And not only the data that we measure, because we measure, we have digitalized, and the moment these models you can feed in only limited amount of data. And this is a biased data, because this is the data we have systems to observe, and we find important enough to measure in some sense, and we digitalize and store. So there is a bias, and there is a limitation in the size of these models. And to expect that with these limitations, you will get some general knowledge and some generalization in a more common sense is just a mistake. To be able to understand the limitations of the system with overfitting, generalization, distribution shifts, etc., you have to understand how these systems work. And to understand how these systems work, they are still based not on a magic, they are based on mathematics, stochastic, probability theory, etc. And I do believe this is super important, as long as we don't have this all-encompassing, unlimited system.
Probably not directly addressing your question, but just to give you an example about how I pursue this from an educational perspective. I ask all my students to use it, and even the students, undergrad students on my class, and writing their final report, all those like non-equation, all those written reports. In the syllabus that I gave out, I add a sentence: ChatGPT is allowed, is recommended, but you have to revise it or you have to make it into your own words, because I can tell if you directly copy and paste that, because I use it very frequently. But in order to get to know a technology, you have to use it, right? You have to know its limitation. You have to know, all those hallucination. ChatGPT is making nonsense, and in some cases they can combine technology in your field. We have students from hydraulics, from geographics, from all those different domains and transportation. How are they able to translate all those knowledge in your domain to a certain answer I gave you? Or they're just making things up. If you don't use it, then you have no idea. But if you use it and you get to know it a little bit more, you know its limitation, and then probably you will be the one to advance this technology in the future.
If I may add just one anecdote, I'll just take 30 seconds. So the last few months I was working on a pretty complex research paper, a lot of complex derivations.
I think I saw that.
You saw that? So,
Still reading it.
oh, okay. So I would have called ChatGPT about 100 times, and it was wrong all 100 times. Maybe it was wrong 98 times, but it was useful for me all 100 times because it was pointing in the right direction. It gave me some, gaps that I knew I could probe more and I could exploit. So I think, that's the thing, does not need to be perfectly right for it to be useful, but at the same time, only if the user has much broader knowledge. At least I wanted to get that out. So also to some people who say, some mathematicians, computer scientists who say this is useless. So it's not binary, right? It can be wrong, but it can still be useful if, we have the experience and exposure to use it. And when it becomes a personal assistant for many other things in our daily lives and in transportation, it would be the same thing. These things will never be perfect. It won't be binary, but there has to be some supervisory, some guardrails and some of our own explicit expertise that manages these things, and it can still be useful even if they don't get more accurate.
I agree. And we've talked about a lot of things here. I think the education, the workforce are very important. We talked about public perception. How do we make sure we can educate the public about its use, its proper use, its ethical use? But the other question I have really is scalability, what you brought up earlier. How do we bring these products to market, right, responsibly and safely? And what might be some hurdles that we need to try to, look into so we can accelerate these tools into the marketplace? So what do you all think the challenges are going to be for scalability of some of these major products, like the ones we saw earlier, for example, and we're going to inject them into the transportation system?
Yeah, I'll go first. So again, looking at part one, where we didn't have any machine learning in the product space in the transportation sector. So traditionally, every model year refresh, you would design all your refresh models, algorithms, products, etc. And you went through your test cycle, your dev cycle, your verification, validation, functional tests, all your homologation, your emissions, 2 years. and you put out a new model on the road, right? Right now, things have changed. All of this stuff is accelerated because of machine learning, hopefully. You're using data, using machine learning, but at the same time, you're injecting. What you're doing now is the testing paradigm is changing. Previously, you knew exactly, well, I've got this new sensor, I run these tests, I collect the data, maybe I run a Monte Carlo, and I do error propagation, and I tell you, well, what's my bound? If it doesn't fit, you change the sensor, you fix an algorithm. Now it's becoming more difficult because we have to know what data to collect, to your point. What kind of tests do we have to do? Do we have enough domain coverage, safety, emissions, if it's emissions related, performance related, and then bring that all together into the system level overview of exactly what we're projecting the performance to be when we put something out on the road. The challenge with autonomous vehicles in general has been that you never have enough data to fully certify. So closing the loop on stuff that's been put out on the road for any number of autonomous or ADAS functions, for continuous learning, with data coming back and refreshing your models, looking at the new learned edge cases, corner cases, just like how you would have fault codes in traditional vehicles. You still bring those back, you have your DTC codes, you fix them. Similarly here, you have to have that loop. It's much more intensive than before. And continuous learning and refreshing is going to be critical.
I want to chime in. And I do think there are industries, transportation industries, where it is much easier, and they will readily pick up Gen AI, LLMs for prediction and planning, path planning in autonomous vehicles, etc. I pick up this question because you ask for the hurdles, not for the solutions to them. So I can point out a couple of them. I come from a trucking business. So I was working for Daimler Trucks before I joined Amazon and AWS. And I was working on the autonomous application for autonomous trucks, hub to hub. And a big part there plays all the transport management system, logistic systems, and how you plan the operations of this truck, how you make it more efficient. This was one of the goals, yeah, besides, alleviating a little bit the driver shortage. I was surprised there were systems running still on IS400. I was like, what is this? Can you repeat? Let me take a note of this system. I didn't have a clue what is it. But like maybe 70, 80% of the TMS, the transport management systems of big carriers were still running on some legacy IBM server. Now, this is one of the big issues. I was going to, preparing for this panel, but also for other speaking opportunities I had. I was thinking one of the beautiful use cases is really optimizing transportation, optimizing flight traffic, making it more safe, etc. All the examples also that we saw from Dr. Yi. Now you have to integrate them into legacy business systems and processes. And I do recognize that this is a big obstacle. How do we do this, especially when your systems are so old? And you have to do it seamlessly. To help really, you have to be able to pick up these old systems and tap the data, build some interfaces that are not there. So I do not have, unfortunately, here the solution, but it is a problem. So what I would do was I part of this industries would be to start with the low-hanging fruits, where integration is not so important, where you can run two tools in parallel, etc.
So I'll give a short answer. I have a startup in Silicon Valley that does AI, and the way to, I think, get these products out is to be honest about uncertainties from the ground up. So at least the way, I'm not saying this is the only way to do it, but the way we approach it is build everything from the ground up to be probabilistic. So whenever you're generating decisions or generating insights, not just generate the insights or decisions, but also give uncertainties associated with them, right? So in that sense, the users can be more informed about not just the answer, but the confidence in the answer. So having that as part of the product, we're not, as a society, we're not used to thinking about it. We think about everything deterministic. Should I do this? Should I do that? Everything is binary or deterministic. But with these tools, if we are really honest about lack of data, lack of coverage, lack of, we're not driving these models to machine precision. So there's so many uncertainties that are abound, and just being honest in accounting. Maybe the market's not ready for it, but we got to create a different perspective on how to use models.
Probably very quickly on to address this question, the limitation of deploy that on our existing traffic infrastructure, right? So probably in our mind, the power consumption or the computing power limitation on those edge devices, if we were trying to deploy a large language model to a roadside unit, then that will essentially eat up all your computing power. And probably also your vehicle onboarding computing power as well. So probably the alternative solution is we actually embrace small models, not necessarily large models. We just use those data that is specific for this scenario. Say if you want to deploy this on a roadside unit at an intersection, you just feed all those data that is related to that. You don't necessarily feed the data about your kid or your dog or your pets or things like that, but just feed in those traffic data at intersection, how those vehicles, they should behave at that. Train a small model, and that small model is still a Gen AI model, but that will address all those issues with this guarantee of getting your results in a fairly efficient manner and without eating up all your computing power and all the powers, electricity power. That's probably the way to go. And then you can probably take that output, take those data to a large language model, to a large model to run that at the background. But to address that limitation, probably small models are the way to go.
Yeah, I really appreciate all your input, and thank you all for your time today. I hope we can all scale our knowledge together in this space over the infinity and work together to kind of understand where we see value in this technology. But again, we have to keep talking. We have to keep coming to events like this. We have to have the discussions open, and we got to keep learning. So thank you all for your time.
Taylor, do we have a couple of minutes to take questions from the audience? Maybe?
Yeah, we have 5 questions. Okay. Yeah, 5 minutes. Yep, go for it.
Hello, I'm Alex. I'm just wondering by chance, since you guys were specifically talking a lot about AI education, stuff like that, specifically around there. Like I do a lot of, I've been like using GPT for a while. I try and make custom models and try and do a lot of stuff. But the main thing I've been wondering is primarily is specifically regarding communication skills. I've just been seeing like a lot of issues, primarily like within social science or other things regarding that with the use of GPT, and I'm wondering like your thoughts on like how that's going to be affecting like the workforce, specifically regarding like a lot of engineers and stuff like that, for how those type of social science skills, such as like cognitive thinking and all those like types of things and communication, are going to, how that directly affects you and your other workers and other things like that. It's just.
I don't dare to generalize and give a general answer, but I wanna answer with a personal anecdote. I'm an engineer. When I was a student, I didn't like to call myself engineer. I was a computer scientist, but today, not knowing better, I call myself a computer engineer or etc. So my communication skills, I don't know if I got your question correctly, but my communication skills, this is not my strength. Yeah, I'm trained in a very formal, classical science, and I use a lot ChatGPT, and my emails became so much smoother and so much more polite, and they are grammatically correct, They have all these, what we call socially lubricating elements to them. And ChatGPT is helping me a lot, also, I come from a company, there are a couple of colleagues where we write a lot, we write a lot of documents. Now there is a trade-off, and it's not a trade-off, but you cannot go and ask ChatGPT to help you with something that's confidential for a company, etc. But if you have some paragraph that talks about general macroeconomic developments, etc., this is something where also ChatGPT is helping me. So I see if. I don't know, Alex, if this was your question, but I think it does help in communication.
I think I'll take a shot. I think verbal, if you're referring to verbal communications, I don't think it's helping. If you go to a conference like a NeurIPS, you will see pretty much everyone sitting down with their laptops, hacking away. Nobody talks to anybody except for when the speakers are talking. So there's another interesting observation that has been made is about our navigation skills, how they're fading away with the use of things like Waze or navigation aids, where people who normally would just drive by northeast, southwest, we're looking at prompts every so often, even, and it probably takes us a few drives before we can get it down, but we're becoming dependent on navigation aids and losing basic human skills of navigation. So I'm thinking that things like this, probably we will be trading off some basic human skills with, some of these digital skills, so to speak. It's probably something that we'll see over time.
Take a quick crack. I've been thinking about it, and as much as I would like to think that mathematics and all of these things are fundamental, we have to learn to live in the era of ChatGPT and these tools, and no choice. And I've been thinking the only thing that's fundamental anymore, I think, is reading. Other than that, everything is, if you want to use the word corrupted or if you want to use the word aided, whatever it is, you have to live in that world. But I think reading is still uncorrupted, in my opinion. But everything else is up for argument.
Yep.
Hello? Hi, my name is Armin. I'm from Snorkel AI. The question I have is mostly around the infrastructure and how Gen AI can help the infrastructure that the autonomous vehicles and in general mobility is going to drive around in that environment.
They say it's my question. I didn't. May you just bring the microphone? How Gen AI can help with the infrastructure on the vehicle, on board compute?
Infrastructure in the cities. Basically.
Oh, in the cities. Oh. No, it's not my question, but
Yeah, I think I can take a crack at that. I think the previous presenter showed some of that in his slides. So city planning, if you inverse the problem, right, before, way back when, going back again to my days at Ford, one of the first thing we did was connected vehicles, right? There is so much information out there through connectivity, through V2X, V2V, roadside units, all of that. And then, everything shifted towards, well, just put a camera on board and forget about communications between vehicles and infrastructure and roadside units and things like that. I'm thinking that if you invert the problem, to create an optimized sensor network, so to speak, to inform autonomous driving ADAS systems and DAT systems, that's something where, since it's a massive problem, you could either do very massive optimization or you could use a generative method to start planning for infrastructure and inform autonomous systems in a way through sensing and information exchange. I think that might be one application.
Yeah, and one of the domains is cooperative driving automation, if you're familiar with that topic area. Federal Highway Administration is kind of leading and looking at how that infrastructure information can support and enable vehicles and how vehicles could support them with information from the infrastructure.
Okay, I think we have time for one more question. So Is there another question or other? And then we'll go to lunch after Kelly's question.
Thanks. Kelly Bartlett from MDOT and also Office Future Mobility and Electrification. The question I wanted to ask, the presentation earlier said sort of the cardinal rule of robotics is a robot should not harm a human. And I wondered if you were to add, what's the next rule you would say after that? Or are there any more rules other than that?
I can try. So my experience with robotics and harming things, the two. So again, I can go back to the defense where I'm now, and I'm just beginning to work on a project where we want to assess the readiness level of autonomous weapon systems, right? So it's a very, already it sounds very ominous. So you want to make those things responsible. How do you do that, right? If now it's a very difficult trade-off problem. You have to comply with the intent of the mission, or what's called the commander's intent, and you also have to be responsible. So that's a very constrained problem, and the solution space obviously shrinks. And so in that space, we are encouraged to use generative AI to create scenarios and then test these autonomous systems or robots to perform in this autonomous or generative sandbox and test for the readiness level. Now that goes back not just harming humans, but behaving in a manner that is not aligned with human ethics, right? So alignment is a big problem in robotics in general. In the non-defense space, if you look at a factory floor where robots are supposedly, if you go to the lights out manufacturing 24/7, all roboticized, there is not only the problem of humans and robots getting into conflict because of maybe the robots just misreading the environment or malintent, who knows. There is also the question that's coming up now is a robot-robot adversarial behavior. And so it's not just humans, it's basically, it starts becoming an ecosystem where either the humans or the robots dominate or some combination thereof. And there is always the potential under deterministic or stochastic uncertainty, because there is uncertainty, of an evolution of a scenario that will create conflict. So understanding that is something that is another area of research that's ongoing right now.
I think do not harm is maybe not always possible. I would say the biggest innate objective should be minimize harm. And I want to give you an example in autonomous vehicles. When you cannot avoid crash, where do you crash? Right. So, and the goal of autonomous vehicles, when we talk about safety, has been avoidance of unreasonable risk. We will, as we operate in a highly uncertain and complex environment, to remove the risk is not possible.
And maybe one of the terms that might cover that is just responsible. I think you can use that term and it could cover a lot of areas and it can be a tree of a lot of different subfactors, but responsible, like you said, I think is probably either the next sentence or maybe a replacement sentence. Safe and responsible. All right, thank you, everybody. I guess now we're ready for lunch. We're going to be around here. We can hang out and talk. So let's meet your neighbors. Let's have fun, and let's enjoy the rest of the day today. Thank you.
Thank you.